Hi, everyone. I hope all are well, safe and healthy. I'm back. I apologize. I missed a few weeks. Life got a little bit crazy for me, but I think I'm right in time for an excellent presentation. Someone who I have been a huge fan of for years. Seema, welcome. And this paper will be co-authored with Josh Dean, who is a colleague of mine. So there will be a little bit of home cooking. He's a wonderful young economist as well. So I will turn it over to Rob to give a formal intro, but I just want to say welcome everyone and thanks for coming today.
Thanks, John. Thank you, Seema, for joining us today. Seema Jayachandran is Professor of Economics at Northwestern University. She's also an affiliate of the NBER and a board member and chair of the gender section at JPAL. She's also a reviewing editor for Science, co-editor for the AEJ Applied, and associate editor of the QJE. So amongst a lot of Seema's research, there's a broad diversity of topics, including children's health and education, which will be a focus for today, gender equality, labor markets, and political economy. She also has, my interest, a lot of experimental research on ecosystem services and trying to understand sort of how to create a payment for ecosystem services in a sustainable manner. So definitely read some of her papers on that area as well. So Seema, we're very happy to have you here today, and over to you.
Great. Thanks so much, Rob, for the introduction, and John for the welcome. And thanks, everyone, for attending today. I'm excited to be presenting this work with Josh Dean, who's also on the webinar and will be answering questions in the Q&A. So the title of the paper is Attending Kindergarten Improves Cognitive Development in India, but Not All Kindergartens Are Equal. So we decided to have a Say What You Found title, which welcome for feedback. We welcome feedback on the title and on the project overall. This is definitely a work in progress. We plan to do at least one more round of data collection, and I think this is a neat project for me to present in this audience because I think some of my field experiments, 90% of the contribution is using purely the experimental variation and comparing treatment and control for some primary outcomes. This is a paper where we're going to do that, but a lot of what we're going to try to say that I think is interesting is adding in some extra assumptions. And so kind of welcome feedback on what people think of that. Let's see if this is working. I'm going to stop my share and try that again. See. All right. Okay, great. So there's been. This is just to start with some facts about pre-primary education in developing countries, and this was just going to be our focus. And you could see that, so here, pre-primary education, this is from Our World in Data, it's defined as before compulsory schooling starts. So it's a little bit different in North America. That would be pre-K, and in most developing countries, that's going to be kindergarten, since compulsory schooling starts in first grade. And you could see that it's about 70% in a lot of the richer regions, whereas in South Asia, it's actually the lowest of any region in the world. It's about 14%. It's been growing, but it's still quite low. And there's a lot of interest in expanding access to pre-primary education. And that's part of the luxury of a lot of progress over the past few decades in enrollment in primary education, which is near universal in a lot of developing countries. And so one of the next frontiers is improving early childhood education. And so most of the government schooling in India and elsewhere is going to start in first grade, but there are options right now for kindergartens, either NGO run or privately run. And as just a bit of notation, we're going to refer to kindergarten, which is going to refer to the 2 years before first grade. So it's when kids are from 4 to 6. So in the US, it would be what we call pre-K and kindergarten. Okay, so does kindergarten work? Well, here's some evidence from The Onion, and this is kind of just reminds us that it is one of the conventional wisdoms, or one thing we all kind of agree on, of the importance of early childhood education. And the Onion writers didn't just pull that out of the air. There's very compelling evidence from the US on high returns to pre-primary education, both kindergarten and then pre-K and preschools from the Perry experiment to the large literature on Head Start. So where we're going to come in is that there's less convincing evidence on developing countries of the impacts of early childhood education. And I think there are reasons why you might not want to extrapolate. Kindergarten, just because it works really well in rich countries doesn't mean it's going to work well in poor countries. The quality might not be as good. There might be absenteeism or teacher quality. I think there are also reasons why kindergarten might be more important in developing countries. And full disclosure, I think this is where I came in thinking this is actually going to be more important in a developing country context. And that's for at least two reasons. So one reason is that the counterfactual to attending kindergarten might not involve as much cognitive stimulation. If at home, parents in poorer settings are less educated, they might not be reading to their children, then the gain kids are getting in terms of stimulation from home care to kindergarten will be larger. Another one is related to not the immediate impact of kindergarten, but how it persists. And it's related to the structure of the education system in many developing countries in primary school and beyond, which is an idea of teaching to the top. So a lot of Michael Kramer's research has pointed to this, that as a legacy of the colonial system, the teachers in primary school might not be aiming at the median student or providing remedial help, they're aiming for the top of the class. And what does that mean? It means if you entered first grade unprepared, you might not learn as much in first grade. And so, a child whose innate capability was at the 75th percentile, if they enter at the 25th percentile because they didn't have any education before, they might learn less in first grade and second grade and so on. And so that means you can imagine more persistence and even perhaps gains after kindergarten. Okay, so one question we're going to try to answer is what is the impact of kindergarten? There's also a question of what type of kindergarten should we be scaling up? And there are broadly two types of models that are prevalent in developing countries. One is a more informal community-run version where it might be an NGO or sometimes governments try to get communities to set them up. And then the other is a more formal kindergarten with a curriculum and trained teachers that I'm calling here US style. And so the best evidence we have on kindergartens is from this first type, these informal community-run programs. So there's a nice paper in Mozambique and one in the Gambia. But the policy discussion at least in India, is focused on this other type, the more formal kindergarten. When we started this in the state we're working in, Karnataka, one of the likely options was to offer vouchers to private kindergartens. I think what seems more likely to happen now is probably just to add it to primary schools, to actually begin compulsory education in primary schools, but started at least in kindergarten, maybe the 1 year before. And so that's what our contribution is going to be, is to, at the very basic level, in a policy, a valuable policy parameter is to estimate the causal returns to formal kindergarten in a developing country. And what I'm going to show you is results at the end of those 2 years of kindergarten, or what would have been kindergarten, and then persistence for 1 year when the kids are at the end of first grade. So sort of start to speak to this broader question of how does the trajectory of these gains change because of the structure of developing countries? And our plan is to collect at least one more round of data collection planned for early 2021. We'll see how that goes, but in any case, kind of when the kids are at the end of third grade, or we might have to delay it a year till the end of fourth grade. Okay, so in this slide, I'm going to remind you of something that kind of we all know, but it's easy to forget, which is that treatment effects always depend on the counterfactual. So if we think about returns to going to college, it's in the labor market, it's always relative to how much 4 extra years of work experience would be in the labor market. We're always measuring a net gain. And so that point is important for the audience members who are familiar with the Head Start literature. That point is important in the Head Start literature, because the early studies were very nice quasi-experimental studies that found a very high return to Head Start. Then there was the first RCT called the Head Start Impact Study that found a positive, impressive effect, but it was considerably smaller than the earlier ones. And and one interpretation that comes to people's mind is, well, maybe as Head Start scaled up, the quality wasn't maintained. What the recent literature has shown is that that's actually not the primary explanation. It's that the counterfactual changed, that in those intervening years, the US, and often it was other government subsidized programs, like were we're providing kids the opportunity to go to pre-K, not through Head Start, but through other programs. So by the time of the Head Start impact study, more of the kids who were going to Head Start would have been going to preschool anyway. And once you take that into account, kind of for the kids who switch into pre-K from daycare or home care, the effects were actually pretty stable in magnitude over those years. And so we're going to do something like this as well. Our analysis is going to take into account what a child's counterfactual activity would have been. And we're going to do something different from what the previous literature has done, something that, probably feels very obvious in kind of with today's sort of the growth of machine learning over the last few years. We're going to predict what a child's counterfactual activity would be with machine learning. So we're going to have a control group. We're going to see what kids do, and that's going to enable us to have, for every child, including the treatment group, a measure, a prediction of what they would have done had they not gotten this opportunity to go to get a scholarship from us. Okay, so what are
Seema, hi.
Yeah.
Would you mind going back a slide?
Yeah.
I just have a quick question. So you've talked a lot about early childhood programs and their impacts on the first moment of an outcome variable.
Yep.
What is the evidence on what happens to the second moment of those policy variables?
Yeah,
And the reason why I ask is because you mentioned earlier that there might be an effect because teachers in 1 through 8 might teach to a certain part of the distribution.
Yep.
So I guess we should tie it back to what these programs do to the second moment of the distribution as well.
Yeah, I know, and that, in fact, that used to be part of the motivation slide that I trimmed in the interest of time. But one aspect of it is just access. So right now, there are the private kindergartens throughout India, and richer kids are going to them. Not rich by by any developed country standard, but within a village, the richer kids. And so what you're getting, that that inequality that's coming not from that's just coming from actual access to education, means that, say, a poorer kid is going to be worse off in primary school, because of this access. So in that sense, expanding access should be shrinking the variance in first grade preparedness, and so making it easier at whatever level the teacher is teaching at, there's less variance around that. So that should be beneficial. In terms of kind of conditional ongoing, what is it? Are some kids learning a lot fast? If 100% went, what happens to kind of learning if you had kindergarten versus not? I don't know the evidence on that or the literature kind of what, and that's going to depend on whether kindergarten itself, aimed for the top or had more remedial focus. I hope that answers your question, John.
Partly. So you went to a theoretical argument about why, some are start really high, really low, you raise a really low ones up, but I could start with everyone low and then there'd be heterogeneity in the impact, and then that increases.
Yeah, no, exactly.
I was wondering, in the data, so you cite a lot of data here, in the data, I get a sense that you're arguing that the first moment moves, and that's fine. We can debate that with Head Start and Abecedarian and Perry, et cetera. But what I'm just wondering is, in the data, what happens to the second moment? Are there facts around the second moment?
Yeah, I don't know them from the Head Start literature. It may very well be in those papers, and I just don't know them. And then I'm not sure we've done that. We sort of have thought about it on this axis, that kind of, if within our treatment group, if some of them were going to go to kindergarten, now we increase that, that variance shrinks. But we haven't thought about it of kind of what you're saying, which is just conditional ongoing. If everybody starts out at the same level and then people are learning different amounts from kindergarten, that's going to increase the variance versus if they hadn't had education during those 2 years. Like, we can do that within our data, and we haven't done that yet.
Yeah, just to say, I suspect that your first story is right. I was just thinking that there are theoretical stories that go the other way too. And I was just wondering if there is a fact around that, but thanks for your answer.
Okay, great. Okay, so what are we going to do? We're going to we partnered with a specific kindergarten provider in rural India that operates many kindergartens in different villages, and we're going to randomly allocate scholarships to attend the kindergarten called Hippocampus for 2 years. So this sort of pre-K kindergarten, or what in India is called lower kindergarten and upper kindergarten. And then we're going to measure the effects on 2 kinds of outcomes: cognitive development and socio-emotional development. And I think we're stronger on the cognitive development measures, and I'll kind of put more emphasis on that, but I'll also show you on the socio-emotional development. And we'll do that at the end of kindergarten and a year later. And then coming back to this point about counterfactuals, and this is where we're going to kind of add to the experimental variation and add more assumptions to try to get out more parameters, which is to try to estimate separate effects of attending kindergarten for this particular kindergarten for compliers who would have had no kindergarten absent the treatment, so who are switching in from no kindergarten, and then a different treatment effect for those who were switching from a different kindergarten provider, so from a different provider to the provider we work with, which they got scholarships to. Okay, so just to preview the results, we have a first stage, so the scholarship increases enrollment in our partners kindergarten by 51 percentage points, and in any kindergarten by 35 percentage points. And we see very large effects in cognitive test scores, the first moment after kindergarten. And then when we decompose it, not surprisingly, that's especially large for those who are switching from no kindergarten. And then we don't see, what I was kind of expecting, which is very strong persistence or maybe an increase in first grade. And I can say more kind of how my view has changed after seeing these results, but we see fade out between the end of 2 years and then the following year, but the effect size that persists is still quite large. And when we sort of apply the Nathan Hendred, Ben Sprung-Kaiser approach of the marginal value of public funds, if these scholarships were through public funds, the marginal value of public funds would be infinite. So these are quite large effects. And then we don't see impacts on socio-emotional development. Okay, so we worked with an organization called Hippocampus Learning Centers. They operate 200 what they call centers or schools in Karnataka, which is a state in South India. And the total cost of attendance, it depends on the village size, but it was in the range of 6,500 to 8,000 rupees a year, which is about $100 US. And that includes everything, the fees, the uniforms, materials. And the scholarship we provided covered 80 to 90% of those costs. So for everybody, there was a copay of 1,000 rupees. I think from Josh and my perspective, we probably would have preferred no copay, but the Hippocampus wanted to have a copay. Okay, so what does a Hippocampus look like? They rent up a plain building in a village and paint it primary colors. Their name, Hippocampus, is named after the part of the brain, but it lends itself to a mascot of a hippopotamus. And then in terms of the teachers, India is unusual in that it has close to parity on secondary school enrollment and then 29% female labor force participation. So there's actually a lot of secondary school educated women in villages. And so that's the qualification for this job, is a secondary school education. And, teaching kindergarten is considered an acceptable job for women in the sense that it's within the village. Kids are not as threatening as male colleagues. And so there is a big pool of usually kind of women before they get married or a few years after they get married, so who are the teachers. Okay, so what are kids doing in this setting absent our intervention? So there are different options kids could be doing for at least a chunk of the day between the ages of 4 and 6. So one is being taken care of at home by their parents usually, or some other family member. That turns out to be not very common at all as the exclusive option in rural India. And that's partly because the government has set up a network where every village has what's called an Anganwadi center, which is a government-run center, and it was set up with a nutrition mission to try to reduce malnutrition, but it also provides daycare. So I think nominally they're open maybe 4.5 hours a day. De facto, they're probably open 3 to 4 hours a day. And they have a mission as well to have a curriculum and have preschool. But because they have many other responsibilities, there isn't much emphasis on teaching. So some other researchers have done something where they did a time use on what Anganwadis are doing, and they teach about 30 minutes a day. And then the third option are private kindergartens. So in most of the villages where Hippocampus operates, there are other kindergartens operating as well. And so, one question is like, how is Hippocampus different from other kindergartens? So first of all, it's operating many schools, these 200 plus schools. Most of its competitors are just single shop organizations where it's often tied to a primary school. So, and they're just operating in the village. So Hippocampus is, it's sort of was started by a former software engineer who wanted to create a model of kindergarten that could be scalable and low cost, that could really reach a lot of people. So from the get-go, it was designed to be low cost and scalable. And the other kind of important distinction from other kindergartens is its educational philosophy is a little bit different. So they worked with child psychologists to develop a curriculum, and a curriculum that, they could kind of what they call, curriculum in a box, where they could train teachers and try to standardize it across its centers. But that curriculum kind of emphasizes the kind of intuitive learning and learning how to learn, and put less emphasis on rote learning than some of its competitors. So as a kind of mundane example, many kindergartens, this seems odd to probably most people in this audience, but kindergartens give a lot of homework, and parents want kindergartens to give homework. Hippocampus doesn't give homework. So it's going to have a kind of a philosophy of higher order thinking skills compared to its competitors. It has pretty bare bones facilities. That's part of keeping its cost structure down. Its fees are pretty typical. The teacher salaries start at $45 a month. That's actually lower than the Anganwadi workers. It's half of their salary, so and it's pretty comparable to other schools. They have slightly smaller class size than other schools, partly because of their kind of growth trajectory of being relatively new. And then maybe because of the no playgrounds, they have students from poorer families than other kindergartens on average. Okay, so the Karnataka is a state in red in South India, and we worked in a subset of the districts where they operate, and we picked 71 villages, 71 different schools they operate in for our study. And in those 71 villages, this fieldwork was done by a great team at JPAL South Asia. The surveyors visited households to identify children who were age eligible to enter kindergarten in June 2016. So that meant they were between 3.5 and 4.5 on June 1st, 2016. So in 2 years, they would meet the kind of official criteria to enter first grade. And we administered a screening survey to identify poor children. Our goal was to give scholarships not to the richer kids in the village who could go to kindergarten anyway, partly from an ethical point, or kind of who you're trying to help, but also just from a practical statistical point of view, because we wanted to kind of encourage people to go to kindergarten. And we asked questions that we thought, we didn't have the ability to verify information, so we asked things that the surveyors could see easily, like ceiling fans and livestock and dwelling characteristics. And we had done a pilot the previous year, so based on that pilot, we had created a principal component measure. So we had weights to aggregate the variables, and we had a sense of what cutoff we wanted to use. So on the spot, a family was told whether they were eligible for our study. So if they were poor enough to be eligible. So we enrolled on average 11 children per village. So part of our, we're going to randomize within villages, and we didn't want to flood too many, or even if we didn't randomize them within villages, wouldn't want to flood the hippocampus with too many new students. So we capped how many we enrolled per village. And so out of this exercise, 888 children were deemed eligible, and 888 chose to enroll in the study. And then we did randomization of scholarships within villages. So unlike some of my studies, this one, it was transparent to participants. They knew this was going to be a lottery. So they knew when they were signing up for the study that there was a 50% chance they would get a scholarship to attend Hippocampus. And so one thing that might raise for you is, okay, is there some sense of, should we be worried about spillovers, either the quality in the hippocampus being lowered by having these extra kids, or maybe some other kindergarten or the Anganwadi has fewer kids now because of this treatment. So we can do a couple things to try to get at that, but just the numbers are relatively small. So on average, the treatment induced 2.5 new kids to attend a hippocampus, because half of those 11 were in the treatment group, and we're going to get about kind of the compliers, it's going to be about half of that. So it's about 2.5 kids. And so if those are equally split from the Anganwadi will have one less child, and then some other kindergarten in the village will have one less child. So I'm not going to show you the balance table, but the treatment and control are balanced. So we
Seema,
did. Yeah.
Hi, Seema. Quick question. Can you go back a slide?
Yeah.
Oh, thanks. So on average, 11 children will be coming per village, so to speak, right? So you have an average 11 children treated per village, is that right?
Enrolled per village, so 5.5.
Okay, 5.5. So you're going to track now those 5.5 treatment versus 5.5 control. And when they leave, and then you're going to try to say something about depreciation or regression. Did you do anything such as keeping the 5.5 kids together or splitting them up when they go to first grade or second grade? Or did you just allow the natural variation to happen?
We allow the natural variation to happen. So most of them are going to go to the government school for primary school. So a lot of them will be in the same school, but they can go to private first grades and yeah, so they're scattered. They're not going to all be in the same classroom environment in first grade, and we didn't do anything to influence that.
Okay, thanks.
Just another quick question, Seema, as well. I'm
Yeah.
sorry, on the same slide. From the screening survey, do you know like how many were not surveyed? So are they like eligible or like not eligible kids that are in these villages but are not part of the screening survey? The reason I've asked is to get 808 from 888 is pretty good. That's really good. Some of the stuff that like John's been doing, I've been doing on getting parents to sign up their kids to programs, it's tough work. So this seems like a really, really great recruitment rate. So any sort of tips or hints or thoughts you have on that would be great.
Yeah, so it's funny, you know, this isn't crazy high compared to, you'll see our retention rate is crazy high compared to my other studies. This kind of agreeing to consent and participate doesn't seem high to me, you know, and it might be just kind of different contexts in developing countries. You know, we were telling them that there was a chance of a scholarship. So there was a, you know, this was about, there was kind of this benefit in that sense. And yeah, so, you know, I guess it's a credit to the JPAL team. So it was door to door, and by the time people did the screening survey, you know, they had invested a little bit of time. So, you know, I don't know that I have the numbers off of my head. You know, someone who didn't have any interest in us, they probably wouldn't be in our screening data. They wouldn't have wanted to do the screening survey, so they wouldn't have kind of entered into this 888 in the first place. So that might be also part of the difference.
Got it. Thanks.
Okay, so we worked with a child psychologist to develop a set of tests, and we did baseline tests of kids and a survey of their parents in May to June 2016, and then we did an end-line 2 years later in February, March 2018, and this is what I was saying, this 796 out of 808 is definitely higher than most of my studies in terms of retention rate, and then we did a second end-line a year later, also had a quite high retention rate. So this is just listing the different test instruments we used. So we wanted to cover different domains of cognitive development and child development. There was no test off the shelf that was perfect for what our needs were, and also that could be used kind of in this environment in villages on tablets and things like that. So we have a bit of a mix and match. And I should say these are all quite, you know, they're all aimed to have to measure broad skills. We didn't in any way tailor this to whatever Hippocampus's curriculum is. So we are going to group them. When I show you some disaggregated results, it's going to be in reasoning, memory, language, math, creativity, and motor skills. And so we pulled some from the first column, there's the Wechsler test, and then we used Dial, and then we did some individually sourced ones, for example, to have intuitive math and creativity, where the commercial tests we weren't satisfied with. And then the last row is we're going to measure sort of separately socio-emotional development. And we're going to do this socio-emotional, we're going to do quite differently in the first end line and the second end line. The first end line, we couldn't get any direct measures of kids to work well. So we use what's often used, which is the strengths and difficulties questionnaire, which is asking parents about the characteristics of their children. At the second end line, we do a better job and have some direct measures of the kids' socio-emotional development. So here's an example, you know, this is part of the matrix reasoning where you could show this on a tablet to a child, and the surveyor and the child can point to the right answer, you know, which is 5 in this case. Okay, so the estimation strategy. So
Seema, so there's something that came up, and I think Josh may have answered it, but I think it's useful for everyone to hear just the practicality of what's going on here. So you have 888 eligible kids.
Yep.
And 808 sign up.
Yep.
But they signed up knowing that if they're chosen, they're still going to have to pay a fee.
Yes.
And So some of those, now you have 80 that didn't set, maybe those are the kids who are most in need, who knows, because the parent knows they can't pay a fee. Or maybe the parent just isn't sure and says, I'm going to sign up and I can always opt out later.
Yep.
And then across villages, you seem to be having a different number of, because villages are of different sizes. So you have different numbers of kids in each cohort. And that might be changing like the student-teacher ratio. So far, all that's been left on the sidelines. Maybe you can comment on, it feels like a different intensity of treatment. Maybe you're going to try to control for that in some way, probably parametrically, but, and also the selection of helping the kids who you think you want to help the most.
Yeah.
Maybe they've been excluded because
Yeah.
of your exclusion rules. So go ahead, Seema,
Yeah.
thanks.
Yeah. So there are two different questions there. Kind of one is, how does this copay affect things? And is that 80 students who said no, or are those the neediest kids? So we actually could, we could look at that. I don't know the answer off the top of my head. Josh might have answered in the Q&A, but we have the asset score of those 888, so we can know whether the poorest ones are the ones who didn't sign up. What we have looked at, which we were not going to have 100% of people take up the scholarship, and so the first thing that came to our minds was the copay, people couldn't afford it, and also the Anganwadi centers offer free meals, and Hippocampus doesn't, so kids also were giving up the free meal. It turns out we can do the Alberto Abadi technique of looking at complier characteristics, and we're not seeing that the ones who say no, like who don't take up the scholarship, are poorer. In fact, the ones who don't take up the scholarship are relatively richer by the measure of our asset test. So it seems to be other factors that are deterring people from taking up once they're in the study and get the scholarship. My speculation would be that was similar to who didn't consent to be in the study in the first place, but we can look at that separately. So that's on the idea of, I certainly kind of was worried about the copay deterring exactly the people we would want to get the most, but it doesn't seem to be. That's what's explaining who signed up and who didn't. And then on the second question of, there's a different, you're right that I said on average 11, it varies based on not just the village size, but kind of how rich it was, so how many people were eligible. I don't know, can you hear this background noise? There's somebody doing some some construction behind me. Can you guys hear this, or is it okay? Because I'll try.
Perfect, Seema.
Okay,
No, it's
okay,
perfect.
then I can ignore it. So and this is sort of related to the spillovers point. So we're thinking of the treatment as we're not taking into account that part of the treatment is that some other poor peers, or came into Hippocampus with you. We're thinking of it as an individualistic treatment, that there aren't kind of that the difference in your peer composition or the class size change is not we're kind of abstracting that from that, as you said. We've done a couple analysis to try to understand if there are those spillovers, if more kids are going into the Hippocampus, is that affecting the quality? We don't see evidence of those kinds of that difference in the nature of the treatment depending on how many people were enrolled or the endogenous take-up rate. So for now, it isn't going to be part of the analysis I show you today.
Okay, thanks, Seema.
Sure. Okay, so we're gonna do a couple different kinds of analyses. So first, we're gonna just do intent to treat. So Y is usually a test score, and we're gonna look at a dummy for whether you're offered the scholarship. We'll put in village fixed effects, which is how we stratified the randomization, and then we're going to control for the baseline tests and gender and age. We can also,
You're on mute, Seema. Sorry.
I'm gonna share my screen again. Okay. So we're going to do the intent to treat, and then we're going to do an IV effect of the effect of attending Hippocampus instrumented with treatment. And here's a first point. I'm going to kind of put off the counterfactual specific effects until I show you these two specifications, but it's a good point to talk about the counterfactuals because, we don't have a valid instrument here. We couldn't instrument for attending kindergarten with treatment because like it's kind of attending any kindergarten because yes, that for some kids, that's what the treatment did. It made them go to kindergarten when they otherwise wouldn't have. But there are also a set of kids who, switch on the intensive margin, so to speak, like they're switching from another kindergarten. And so that would be a violation of the exclusion restriction. So what we do have an instrument for is for attending Hippocampus, like this specific kindergarten. We can also use years of attending Hippocampus. You'll see that the scale kind of for every kid we induced to go to Hippocampus, it was 2 extra years of Hippocampus. The one violation of the exclusion restriction here is an income effect. For families that would have sent their child to kindergarten anyway, now it's cheaper because they get this scholarship. And here we can look at whether if you get the scholarship, does it lead to more spending on other educational expenses? And it doesn't. And just from a sort of bounding exercise, for this $90 scholarship amount, if you think that's kind of going through nutrition or something else, the effects seem far too big to be explained by this income effect. Okay, the result. So here's the first stage. So getting offered a scholarship increases your likelihood of ever attending kindergarten by 20 percentage points, and it increases your likelihood of ever attending Hippocampus learning centers by 47 percentage points. So, the second column is going to be what we're going to use as our first stage when we do IV. There's a 47 percentage point increase in attending Hippocampus. And so where is that coming from? You could see, and maybe let me start with the means at the bottom, kind of 44% of our sample is ever attending another kindergarten in the control group. So, even though we gave an asset test and to try to focus on poorer kids, a decent portion of our sample is attending another kindergarten. And that's because maybe we mismeasured that and what we measured were not perfect. It doesn't capture all of wealth. It's also true that wealth is not the only factor in who sends their kids to kindergarten. So, parents care a lot about education in India, and so even kind of poor families sometimes send their kids to kindergarten. And then the last column, kind of going to Anganwadi, that's the most common option in our sample. And these don't add up to 100% because there's ever in the title and there are 2 years, so you could do 2 different things in the 2 years. So most of our sample is coming from, is in the Anganwadi Center, and you could see that home care in the middle is pretty low. It's only 10% of the sample is ever just keeping their kids at home without going to the Anganwadi, at least for those 3 to 4 hours a day. And then if you see where is our treatment coming from, where are the compliers coming from, it's basically evenly split between these 3rd and 5th columns. Like about half are coming from the Anganwadi, from this moving on the extensive margin of going from no kindergarten to kindergarten, and then half are coming from another kindergarten where, they preferred another kindergarten, but if you make Hippocampus close to free, they'll switch. Okay, so here's our first set of results of our treatment effect. So this is the total cognitive test score, and starting on the left with the baseline measurements, you could see the treatment and control are very close to each other. Then when we go to the right, 2 years later, a gap has opened up. The treatment group is about 0.4 standard deviations above the control group. And the way we've normalized this, and I should say the tests were identical in the baseline and the first end line. If you have multiple wrong answers in a row, they stop, but it's exactly the same test subject to that stopping rule. And so we've normalized this in the exact same way at baseline and end line, just to kind of go to make these even the standard deviations even more comparable. So this allows us to see, like in the control group, over these 2 years, what was the growth in test scores just from the mix of activities kids were doing, half going to Anganwadi, half going to another kindergarten, and you see that they gain 1.4 standard deviation. So that's just another benchmark to think about, is 0.4 standard deviations as a reduced form effect, big or small. Here's the cumulative distribution functions. Hippocampus was worried maybe if with very poor kids, they wouldn't be able to learn because they're malnourished or something like that. We actually see gains pretty much across the distribution. We don't see heterogeneity by baseline test scores, for example. here's the results of this regression. The first column is exactly the figure I showed you 2 slides ago. We see this 0.39 reduced form effect of getting offered a scholarship. And column 2 is the IV estimate that I laid out on the slide, where we're instrumenting for ever attending Hippocampus with getting offered a scholarship. And you see for every child induced to attend Hippocampus, there's a 0.83 standard deviation gain in test scores. And so, if you're familiar with education interventions, this is a big effect. And then column 3 is we can also make the endogenous regressor years attended Hippocampus. That's basically just divides it by 2. Okay, so just to put the 0.83 in a little bit more perspective, if we go to the control group and look at the kids who were using the Anganwadi or being taken care of at home, who weren't going to kindergarten, their growth over these 2 years was very close to 0.83 standard deviations. So if you want to take this kind of cardinal value of standard deviations very literally, it means that attending Hippocampus is basically doubling the cognitive gains compared to that natural growth. Another benchmark is the Head Start Impact Study, and there are caveats to comparing standard deviations across settings, but that cohort that received 2 years of Head Start, they have a 0.28 IV effect of attending Head Start. So this effect size we're seeing is quite a bit bigger than the comparable Head Start effect. This is now socio-emotional development. Here we see nothing. And so the first column is our index of all of the different measures in this questionnaire. And you could see not only is the point estimate close to 0, but the confidence intervals are going to rule out effects similar to what we see on cognitive development. And then the other points are the different domains of that. And I think when we got to this point, we weren't sure how to interpret this. One interpretation is, well, this is just asking caregivers. It's, parents don't have a benchmark. They don't know how to answer this. This is not great. So that's one explanation. I think there's another explanation, which is that, if you think about kids' counterfactuals, like very few kids are getting taken care of at home without other kids around. So here, and this is different, I think, than a lot of the US context where you're getting kind of early childhood interventions. So most of the kids, whether they were going to Hippocampus or not, they were in an environment where at least 3 hours a day, there were a lot of other kids around them, and they were with someone whose vocation was caring for children. So the Anganwadi workers, might not be trained teachers, but they select into that for wanting to kind of help the community and help children. So it's, it's quite, I think another explanation is that what matters for socio-emotional development is less a formal curriculum and more interaction with kids and a sort of, compassionate caregiver.
A quick question, Seema, sorry.
Yeah.
Was this like a before versus after? So was the same question given to the caregivers before treatment and after? And secondly, so go ahead.
Go ahead.
As I say, and then do you think that there's any sort of parents or caregivers believing that, I should give a low score even if I'm in treatment, because a low score, they might give me a scholarship again for next year? Do you think any of that going on?
Yeah, so there could be some of that, and I'll show you something later in the talk that's like very much suggestive of people were strategic in some of their answers. Yeah, we didn't do this at baseline, so this is just an end-line measure, which also means we could have tightened up standard errors if we had some pre-measures. Yeah, I think my best answer to this is that I shared some skepticism, kind of at this point. And I think by the time we get to the second end line, we're going to have better measures and we're going to continue to see this result. So in the end, I moved my prior that this isn't just measurement or that it is kind of related to probably that the counterfactual involves a lot of socio-emotional stimulation in this setting. But yeah, I take the point on some of the concerns with this measure.
Great, thanks.
Okay, great. So now let me talk about the counterfactual-specific treatment effects. And here's where we're going to add, IV already added some assumptions, but here you're going to see we're going to kind of add some more estimation to try to pull out 2 different treatment effects. Okay, so, as I've been saying, kids attended Hippocampus from different alternatives, and we're going to lump them into 2 groups. You could break out Anganwadi and home care just for statistical power reasons. We're going to conceptually think of it as Anganwadi and home together, or coming from another kindergarten. So these are compliers we want to kind of estimate an IV effect, where we get the local average treatment effect, where the compliers are the ones who shifted in to kindergarten for the first time versus the ones who are shifting between providers. And, kind of arguably, the first parameter is, what you were sort of thinking about it for the policy question of, should we be putting more money into kindergarten and giving more kids access to kindergarten? So that's case A. And so if you want to know the parameter for case A, you need to separate these two out. But case B is also relevant. It's whether Hippocampus is better or worse than other kindergartens. You want to know that. Maybe if they're a lot better than other kindergartens, then the effect you would be getting is going to be smaller if you used a whole plethora of kindergartens to provide vouchers, or and a voucher system probably won't just focus on one provider. And conversely, if Hippocampus is worse than its competitors, we might have been understating if we just think about what the effect is. Okay, so there are going to be two steps to this, and the first step is predicting what a child's counterfactual would be. And so we observe in the control group what kids do without the scholarship, and so that's going to be an outcome we're going to put on the left-hand side of a regression. And we originally planned to have a horse race between two different approaches. So the approach one is, compared to a lot of the other studies in this literature, we were interested in this from the get-go, and we were collecting our own data. So we just asked parents what they were going to do if they didn't get the scholarship. So we asked them, a few weeks before they were enrolling, we asked the primary giver and caregiver, and we asked what they thought their spouse thought. And we told them that we weren't going to use this to decide who should get a scholarship or anything like that. And so these definitely have predictive power over what people do. They don't have as much predictive power as we wanted. Like, we couldn't use this as a separate instrument. And this is what I was alluding to Rob, that here it looks like people kind of shaded down, even though we see a lot of our control group is attending other kindergartens, kind of everybody says they're not going to be able to afford kindergarten. So they seem to want to, even though we never actually looked at these data for a year, people thought we were going to use this to determine who would get a scholarship. So in the end, we kind of, instead of having a horse race between two techniques, these variables have predictive power. So we're going to use them in our second technique, which is machine learning. And so I'm not going to go into the technical details. We can do that in the Q&A, but we're going to follow Chernozhukov's et al. And a follow-on paper by Crépon et al. That is basically just a technique to think about prediction and use heterogeneous treatment effects based on that prediction. And what we're going to predict is years of kindergarten. So we didn't see variables really separating who goes to Hippocampus versus other kindergartens. And so what we're going to predict is years of kindergarten. And then you'll see, like, IV is going to project the prediction onto what we want. Okay, so that's the first step. Now we're going to have a prediction of what kids would have done, and we can now kind of use that predicted value in the control group rather than the actual, and we have a predicted value in the treatment group, and we don't observe that potential outcome. And then we're going to follow Peter Hull's recent kind of write-up about estimating counterfactual-specific lates. And the kind of idea here is we're going to have two endogenous regressors now and two IVs. So the two IVs are going to be treatment and its interaction with this predicted years of kindergarten. And the two endogenous regressors are going to be the activities that you could do other than going to Hippocampus. So it's going to be the mutually exclusive and collectively exhaustive set of alternatives. So one for us is going to be going to another kindergarten, and the other is going to be not going to kindergarten. And we would expect both of those, getting the treatment, getting the scholarship, is going to make both of those drop. And why do they drop? We think the only reason the scholarship should be causing either of those options to drop is because it's moving kids into Hippocampus. So, it's, in principle, you could break up the counterfactual in more granular ways and have more instruments and endogenous regressors. So this is where we're making a key assumption in kind of using this as IV, because we're going to kind of have two IV coefficients now. You're going to see two lates that are the late for people who came from no kindergarten and the late for people who came from other kindergartens. And so in kind of jumping to IV, we're going to be making the assumption that if we see heterogeneous IV effects for people with a low versus a high predicted value of going to kindergarten, that heterogeneity is coming from what their counterfactuals were. So the reason we're going to see heterogeneity is because of what they were doing other than Hippocampus. And so, that's not an innocuous assumption. Maybe the people with a high predicted value they had a learning style that was very well suited to hippocampus, and they learn more. So that's one of the, we're making an assumption that that's not going on. And so, I want to be upfront that that's a strong assumption, but what it gets us is it sort of allows us to project this. So Alberto Abadi has done some work on it, on sort of thinking about it, doing this heterogeneity by predicted values. This extra step of IV allows us to get parameters that are kind of for these specific counterfactuals we're interested in. So one thing that's on our to-do list is just to at least look at the sensitivity of this. We can repeat the procedure, taking out different variables from the lasso set, and then we can also repeat it just using supply side measures like we have of, distance to the hippocampus, et cetera. Even the supply side measures, you might say they're not perfectly exogenous, but I still think these exercises will help us understand, how sensitive is this. Okay, so here's the first stage. We're gonna have two first stages now. So one is, did you go to home care or Anganwadi, and the other is, were you going to the other kindergarten? And the two first rows are two instruments. We're going to have treatment and treatment interacted with predicted years of kindergarten. So there are a lot of stars, but in some ways stars are not really helpful in understanding, are these first stages strong or weak, or how do we want to think about this? So here are just a couple coefficients you can think about. So this coefficient is for people who have 0 predicted years of kindergarten. We expect they're getting home care or Anganwadi, and so we expect getting a scholarship to reduce going to home care or Anganwadi depending on the take-up rate of the scholarship. And so it should be negative. We don't have a great sense of, what it should be. Theory doesn't tell us whether it should be big or small. Where we do have a stronger prior is that this coefficient should be half the size and the opposite half the size and the opposite sign. And the reason is, if you were predicted to have 2 years of going to a private kindergarten, then you should never be going to home care or Anganwadi. And so getting the scholarship should have no effect on whether you went to Anganwadi or home care. So the net effect of treatment, if you had 2 years of predicted kindergarten, should be 0. And so, and you could see this 0.227 is roughly half the size of the minus 0.413. Similarly, you'd have a prediction that this coefficient should be 0, because if your predicted years of kindergarten were 0, you should never be attending another kindergarten, and so getting a scholarship shouldn't affect this. It's like III. Okay, so now what do we do with those predictions? So first, before I show you the IV, if you are uncomfortable with the IV assumptions, we could kind of just stop at, let's look at heterogeneous IV effects for the people who have a high predicted value of going to another kindergarten or a low predicted value of going to kindergarten. And this column 1 is, these are the probably poorer kids who have a below median prediction of going to kindergarten. And we see that the IV effect of ever attending Hippocampus leads to a over a standard deviation effect on their test scores. Whereas the above median, it's still pretty big and significant, but it's smaller. And those two, if we do it in one regression, those are significantly different. So column 3 is where we project this onto these two specific counterfactuals of going to Anganwadi or home, that's the 1.355, or going to another kindergarten. And so what are these estimates saying? It's saying, for the compliers who were switching from no kindergarten, there was a 1.36 standard deviation effect on their test scores. For the ones who were switching from another kindergarten, there was a 0.44. So, if you can get kindergartens of the quality of Hippocampus, you can get this 1.4 when you get kids who are not in kindergarten to go, and Hippocampus, they probably love this 0.44 the best. They're better than their competitors, and those two coefficients are different. Okay, going now to the second end line, persistence of the effects. This was conducted when the kids were 7 years old. We mostly used the same tests. When things started to look like there was bunching at the top, we took out those too easy modules, and we added some extra modules on topics to just kind of beef up those sections. And then here, and I'll say more about what we did, we added socio-emotional measures that directly test the kids. Okay, so this is the results that are comparable to what I showed you before, where before the reduced form was 0.4 and the IV was 0.83. You see now we're getting, we continue to get large and statistically significant effects. This 0.43 is larger than the Head Start effect immediately, but it's about half the size of the immediate effect. So we see about 50% fade out at the end of first grade. And this proportional fade out of 50% is quite comparable to the US literature as well. So we're not seeing that kind of what I was expecting of this sort of persistence. Now having kind of talked to more people about this, it doesn't seem like first grade is where this teaching to the top kicks in most developing countries. It might just be third grade, fourth grade where that kicks in. So, it's still quite possible that we'll start to see this benefit of being at grade level become more important in how much you learn in fourth grade and beyond, or this idea that there's like an interaction between pre-primary and the structure of the curriculum in primary school, that we were motivated by isn't as important as we thought. Okay, so now this is the second kind of aspect of this paper where I'm going to have some speculation or definitely go beyond the experimental evidence, not by adding extra kind of econometrics, but just in terms of interpretation of the next two slides. So the first, I think, interesting pattern is where we see fade out being the largest. So the dark bars are the first end line, and we see we had the largest effects for math and language and then memory. And those are also the domains where we see larger fade out. So by the time of the second end line, we're seeing pretty comparable effect sizes for creativity, reasoning, memory, language, and math. So another way of saying that is that the fade out was larger for these sort of more, these aspects of learning where there's a little bit more memorization, and this higher order learning, there's less fade out. So the persistent part of whatever Hippocampus was teaching kids was the part that seems to be more higher order learning. So that's, fact or interpretation number one. Here's another interesting or surprise to us, which is these are now the counterfactual specific lates at the second end line. And you could see, the standard errors are really large. We can't, neither of those is different from zero, but if you look at the point estimates, they're very similar. In fact, the other kindergarten, the bottom coefficient, which is for kids switching from other kindergarten, is actually larger than for the one switching from no kindergarten. So whereas at the first end line, we saw kind of all the gains were for kids or most of the gains were coming from the extensive margin, what we're seeing is the persistent component of the gains is whatever seems to differentiate Hippocampus from other kindergartens. So it's not kind of it's not where they're duplicating what other kindergartens are doing, it's their distinctive piece. And so now, Hippocampus might differ from its competitors in many ways, but just kind of like thinking about what is their philosophy and where in our anecdotal observations are they very different, it is this emphasis on higher order learning. And so, I put this fact and the previous fact together and say, not all kindergartens are created equal, and in particular, curriculum matters. It seems to be that, here's like one extreme interpretation of this. If you're just going to teach kids to memorize numbers, maybe they can just play between ages 4 and 6, and making them sit in classrooms and learn isn't important. If you are going to really get those gains and you want to have them in a learning environment, you should be emphasizing these kind of higher order thinking skills, because that's the component of learning that seems to persist. Okay, socio-emotional, I previewed that we did direct measures, and really kudos to Josh for finding these different measures. It's challenging to find ways to measure 6-year-olds or 7-year-olds in the field. So one, we did a picture-based Big Five and measure conscientiousness. We measured prosociality with a dictator game using Candy. We measured motivation with they could do some more Ravens matrices and choose the difficulty level. Did they want easier or hard? We had a neat one where you have to recognize emotions and which emotion is different from the other from photographs. And then we had one where there's a class monitor role in first grade. So just were you in that leadership position? And we again see no effect. So here the standard errors are larger, so we can't reject things, a larger effect, but we're not seeing strong evidence of an effect on this socio-emotional development. And in fact, where where the point estimates are higher, kind of motivation and leadership, this gets into a gray area of, are those socio-emotional, or are those kind of also kind of like grit and wanting to learn. So that aspect of non-cognitive skills, as opposed to just sort of socio-emotional and interaction with others. Okay, so just to wrap up, we find that attending kindergarten has a large effect on cognitive development, especially compared to daycare and home, but also compared to this style of kindergarten is also better than its competitors. And when we think about, this is a social venture, it wasn't government involvement, and there are different options for scaling up kindergarten. But if you use public funds to give scholarships to this kindergarten, the marginal value of public funds would be infinite. And that's because, if we just take from the literature estimates of these standard deviation gains and think about future income and future VAT taxes they'll pay, that's going to more than pay for the initial costs. We don't see an impact on socio-emotional development. We don't have a smoking gun to nail the interpretation, but I think this is one. I think there's a recurring theme through all of this, that counterfactuals matter. And here the counterfactual is that kids are interacting with other kids and having a caregiver, and that maybe is more important than pedagogy. It isn't to say that pedagogy can't make you play well with others. It's just that, at least kind of in the range we're seeing, the other interaction might be enough. And then curriculum seems to matter a lot. That Hippocampus improves cognitive skills more than its other kindergartens, and we're seeing the gains that persist or those that differentiate them from other kindergartens. Whatever that is, something that differentiates them is what persists. And we know that one thing that differentiates them is their philosophy on curriculum. And we're also seeing less fade out for these higher order thinking skills. And so, I think kind of thinking about scaling up kindergarten, you want to think hard about what you're emphasizing in the classroom. And then, as I said, our future plans are to continue to track the kids at least one more time, and hopefully longer, to see, do the effects, do we see, they've leveled off and they persist at that point for standard deviation IV effect, or do we see continued fade out? So thanks very much.
Great, thank you, Seema. That was fantastic. John, do you want to ask any questions? I know we're a bit over time, but.
Yeah, absolutely. No, that was really good. Really great stuff. Just one quick question. So this is just a wonderful research agenda and really nice presentation. When you talked about fade out, you tended to focus on details of the topic, like you talked about math, et cetera, and you focused on curriculum, you mentioned at the end critical thinking, and that's all great, but it's not variation that you have in your data, but variation that you do have in your data are what I would call properties of the situation. So the teacher-student ratio that was in the original class, how big the village is, whether the parents are involved, baseline scores, et cetera, et cetera. It feels to me like to look more deeply into the fallback or the fade, it might be useful to look at some natural variation that you have in your data and see where fallback occurs the most, fallback occurs the least, and maybe go into it with some theories about, like in Chicago Heights, when we kept our kids together who went through our program, there was much less fade out than when they got separated. So the theory there was, of course, there might be some teaching to higher percentiles, and when they did that, our kids were all together. Or it might be that they're teaching to the mode, and when they did that, maybe when our kids are together, the mode is higher or something, the median's higher, whatever it might be. But you seem to have a lot of natural variation like that in your data that you don't leverage. And I was wondering, maybe you have leveraged it and you just didn't have time today to talk about it. Maybe if you can give us some insights on that.
Yeah, no, I think that's a really good suggestion. There's a lot of, we know a lot about the home environment that's, from baseline, and then we also have characteristics of the hippocampus. We also have some information on, we know, I didn't say we don't see an impact on attending first grade. Almost everybody attends primary school, but there is differences in whether they went to private schools or government schools. So we could certainly, we haven't done this, but I think it's a good point, both to think about what's the heterogeneity in the baseline effects, but especially on this question of fade out, because it is one of our, it's like one of our comparative advantages. We're going to have multiple measures of these kids, and so just understanding what is explaining those trajectories with some of our data, we can do and should do, and we haven't done that yet.
Yeah, so that's super. One quick follow-up before Rob takes a question, then maybe that will be the last question, Rob. So when I don't know this literature that well. I know the education literature in the US, of course, but in this part of the world, if you exogenously increase human capital, or let's say schooling, what does that map into? How good are our estimates of what that maps into in terms of quality of life or earnings, et cetera? Because you mentioned earlier that if you do Nate's calculation, that it ends up being infinity. And I'm wondering where you're getting that from in terms of mapping it back to something that we can believe in terms of human capital, exogenous changes now, not natural changes, exogenous changes, because you don't have natural, exogenous that lead to real outcome differences.
Yeah. So we're not, we're using, in fact, Chris Walter's estimate of, standard deviation. And so then the question is, is that which is about a return to education, or, a return to test scores. And so we don't have good estimates of the returns to test scores in developing countries, but the returns to schooling are very comparable in poor countries and rich countries. So, India is not Indonesia, but kind of everyone's familiar with Esther Duflo's job market paper, where the returns to year of education are in the 7 to 8% range in Indonesia. And so people have done Manserian regressions in India and elsewhere, and they're all going to be on the order of 8% or 10% a year. And and people have looked within sectors, like even in agriculture, there are high returns to education in terms of income. So it is a stretch to kind of assume that that there's going to be this high return, or standard return to learning in our sample, but kind of the existing literature on developing countries ends up lining up quite well with the US literature in terms of returns.
I'd also just say the paper presents the MVPF under a variety of assumptions of the relationship between the test scores and the ultimate income. And we still even find, if you look at if you just assume a 2.5% increase for every standard deviation in test score, the MVPF is still like 7. And so even with a pretty conservative relationship, you still end up with a pretty high return.
The Chris Walter's benchmark is that for every standard deviation, you get a 10% increase.
That's where the infinite comes from.
Yeah, so if we get a quarter, I guess Josh is saying we have a pretty high MVPF, even if we slash that by 75%.
Yeah.
Okay. Super, thanks.
Great, thanks. So one last question, Seema, is given that there's obviously a lot of students and young researchers listening, what would you do differently if you can go back and start the experiment again? And what sort of recommendations do you have for students and researchers doing research like this?
Yeah, well, okay, you're inviting people to have regret. That's the problem with collecting your own data. There's lots of opportunities for regret. Well, here's one thing. This is probably the most involved project I've done with machine learning, and so one thing in hindsight is that we should have collected more data on kids of just given test score, given our baseline tests, and figured out what they did for kindergarten. So, we kind of have this whole sample where we're randomizing you and giving you a treatment. There's for machine learning, it's helpful to have more data. So imagine we had also had another sample of kids, in other villages, where we just said, we want to test you and find out, and we're going to call you later and figure out what you did. And all we're going to use you for is to improve the prediction. So, that actually wouldn't have been that expensive. We wouldn't have been giving them $200 scholarships and tracking them for 5 years. And that would have helped us with the prediction. So I think kind of the machine learning, and Esther Duflo makes this point in a lecture she's given, kind of the trade-off when this is not a cluster randomization, but the trade-off between number of clusters and units per cluster is different when you're starting to try to do machine learning. And this is an example where there was some auxiliary data collection I wish we had done. I think the kind of more baseline data collection, working in schools is challenging because you're tied to a calendar. We needed to get the data we need to launch in June, or we would have to wait another year. But I wish we had done a better census of the other kindergartens and the market. I think we could have done something fancier in terms of the market structure for kindergarten in a village if we had done a census of other kindergartens beforehand. So yeah, I think probably more baseline data collection is my biggest regret.
Got it. That's super helpful. Thank you, Seema. That was a great presentation, and thanks, Josh, for answering all the questions.
Yeah.
So go ahead, John.
No, it's really good. I just want to say thanks again. So go ahead, Rob. You should close it and make a last...
Yeah. So next week it was supposed to be Michael Greenstone giving a talk on the demand for clean air, but his presentation and paper won't be ready in time. So we decided to have a week off. We'll save you all next week, and you can have an extra hour in your day. So there won't be a seminar next week, and we'll follow up with a seminar on August the 12th. And that's to be a little bit different. We're going to do a special session on understanding LGBT plus discrimination in a range of different markets. So we have David Schwegman looking at the mental health market. We've got Patrick Button looking at also sexual identity and gender identity in mental health care, and Sandra Maximiano on discrimination in the housing rental market. So we'll see you all in 2 weeks. It'll be an hour and 20 minutes for that session, but we hopefully you all can participate and come along, and see you all then. Okay, thank you all.
Thanks.
Thanks again.
Take care.
Everyone, stay safe.